So today's going to be a pretty quick day. All we're doing is doing an entrance slip covering the powers and exponents unit that we've been working on recently. Basically, what's going to happen is hopefully by now you would actually already finished the entrance slip, but if you haven't, I'll post each question, I'll show you what they are, give you a second to work on them, and then I'll go over them and show you how to do them. Anyway, today's going to be just really good review on this. Let's get started. So, like I said, quite a long entrance slip. Work on this on your own, by the way, if you haven't already done it. When you're finished, just flip it over and sit quietly. We're going to go over it together as a class. The remainder of class, however, after we're done this, we're going to work on our exponent laws booklet. That's something I would have given you last class. We'll worry about that when we get there. Anyway, here we go. First of all, question number one. If you've already had an entrance slip, you're ready to go on this one. If you weren't given an entrance slip or you don't have them today, you can just pause the video here and give this a try. But aside from that, I'll go over this. The question is just asking us to simplify this exponents expression. What simplify means is write this as a single power. Now, what's kind of funny is we see 1 over 4 to the power 6, 1 over 4 to the power 2, but then this 1 over 4 right here doesn't seem to have an exponent. Remember, when something doesn't have an exponent, or at least doesn't look like it has an exponent, the exponent is actually a 1. Some people think you can just glaze over that, or some people even think that the exponent is 0. That's not the case. We have an exponent of 1 there. Anyway, long story short, because all of these are butted right up against each other, we're really just multiplying each of these together. And when you're multiplying powers that have the exact same base, like these all have a base of 1 over 4, when you're multiplying powers with the exact same base, you just add the exponents together. So what this is going to be is we're just going to add 6 plus 2, which is 8, plus 1, which is 9, and then 9 plus 5, which is 14. We're just going to have 1 over 4 to the power of 14. And that right there is a totally acceptable answer. That's what I would box personally. But if you want to go one step further, and I don't mind if you do this, you could therefore say that this 14 applies to both the 1 and the 4, because remember, if you have a power of a quotient, a power of two things dividing, you can just apply it to each piece. So long story short, what I'm trying to say is you could say you have 1 over 14, or sorry, 1 to the power of 14 over 4 to the power of 14. Both of those things I just boxed there are acceptable answers. I would accept both of them any single time. But yeah, it's up to you which one you'd prefer. Anyway, next question. Simplify that expression right there. This one's a little bit more tricky. If you've already done it, great. If you haven't, pause the video here. And I'm going to go over this one. So basically what's going to happen is if you look at the top of this fraction, we just have negative 5 to the power 3. There's nothing else going on up there. That's the only thing that we have. But on the bottom of this fraction, we have negative 5 to the power 2 times negative 5 to the power 7. When you're dealing with a fraction, you can consider the top, in other words, the numerator, in its own set of brackets that need to be fixed up first, and the denominator, or in other words, the bottom, in its own set of brackets as well that also need to be fixed up first before you do anything with this divide sign in between. Remember, a fraction is just the top divided by the bottom, right? Since there's nothing going on the top, but we have quite a bit going on the bottom, I'll simplify the bottom first because we have to save that division piece for last. So the top, I'm just going to leave the same. It's just negative 5 to the power 3 over on the bottom. Since we're multiplying two powers with the same base, we can just add those two exponents together. That gives me negative 5 to the power of 2 plus 7, which is 9. Now this is a lot simpler, but we can go a little further with this one to fully simplify it. Negative 5 to the power 3 over negative 5 to the power 9, because they each have the exact same base, we can simplify the exponents. Remember, when you divide two powers, that's what the fraction is. When you divide two fractions or two powers with the same base, you subtract the exponents. So this becomes negative 5 to the power of 3 minus 9. I'll even write that out, 3 minus 9. And that, of course, is negative 5 to the power of negative 6. That right there, perfectly acceptable answer. It's awesome. Now, some people, just in case you're wondering, some people kind of cringe at the idea of a negative exponent, and I don't blame them. So some people would actually change this a little further. I don't expect you guys to do this. That's fine. But like this, what we put in the box is what I would expect you to do. But this next step, I wouldn't expect anyone to know. But if you do, it's great. Some people just say, hey, you know what? If we had 3 negative 5s on the top and we had 9 negative 5s on the bottom, wouldn't these just cancel out with 3 of these to drop that down to 6? And then we still have like just 1 left over on the top. You could also write this answer, therefore, as 1 over negative 5 to the power of positive 6. That actually means the exact same thing as negative 5 to the power of negative 6. Do you need to know that? Not right at the moment. You don't. This, honestly, is a perfectly fine answer. But if you somehow got to this one, that's correct as well. Anyway, next question. Oh, word problem. All right. So the population of Calgary is expected to double every 20 years. If there are 1.1 million people in Calgary right now, how many people will live in Calgary in 100 years? I'd like to see you guys do this with a power statement. Pause the video here and give it a try. Otherwise, I'm going to go over it. So 100 years is like 5 sets of 20 years, is what I'm trying to say, right? So like 20 years passes 5 times in 100 years. Well, these population questions, we've seen them before and they always cause us trouble. Population questions can be solved with a little formula that I go, okay, the first piece is your starting population, and then multiply by, this is like your multiplication factor. Are you doubling? Are you tripling? Like, what are you doing? So if you're like doubling, you're going to multiply by 2. If you're tripling, you're multiplying by 3. If you're quadrupling, you're multiplying by 4, and so on. And then the hardest part for most people is the fact that the exponent on this is going to be the number of times that this happens. If we apply this little formula to this question, you can see that our starting population is 1.1 million. Multiplied by, you can see we're doubling every 20 years. So we're going to multiply by 2. And then since it's every 20 years, but we're talking about after 100 years pass, the number of times that this happens is 20, 40, 60, 80, 100. That's 5 different times. So 100 divided by 20 is 5 times. So again, before I actually evaluate this, it's our starting population of 1.1 million multiplied by 2 because we're doubling to the power of 5 because it's happening 5 times. That's how many times 20 years passes over the course of 100 years, right? Anyway, this is good to throw in your calculator. If you want to do BEDMAS on it, that's even better. BEDMAS would say you got to do brackets first. We have no brackets though, so you move on to exponents. 2 to the power of 5 we can evaluate first. Let me just write this down. 2 to the power of 5, I'm pretty sure is 32. So really, we're just going 1.1 million times 32. And I think I have an idea what this is, but I'm just going to make sure in my calculator. Oh yeah, I would have been off actually by a little bit. Somehow my mental math would have been off. Anyway, here's a number, 352,000,000. That's 35,200,000 people. Don't know if that question's accurate. That'd be a lot of people to be in like the Calgary area. I'm sure that there's other factors that would play a role in that, but it is still really important to note that population growth questions can be pretty ridiculous. Like the population can grow quite quickly over a certain period of time. Anyway, next question, question 4. Find the perimeter of this right triangle. Give you a hint. This is a Pythagoras question. You can pause the video here. And anyway, I'm going to go over it. So like I said, it is a Pythagoras question. The reason I know that is this is a right triangle, and we're missing one of the 3 sides. If we're asked to find the perimeter, remember the perimeter is just the distance around the outside edge, right? So if we're walking around the distance of the outside edge of this triangle, we know that we can go 6 centimeters here, 14 centimeters here, but then we have no idea how far we're going on this side. So we have no choice. We got to use Pythagoras. Well, Pythagoras is going to say a squared plus b squared equals c squared. Now, the only one of these 3 letters that really matters is C. C is your hypotenuse. That is the side across from your right angle. So we need to make sure that when we set this up, that our 14 centimeters represents our C. Anyway, throw the numbers in. I'll just say this is A, and I'll say the missing side we have is B. So this will be 6 squared plus b squared equals 14 squared. Our goal here is we want to find what b is, because b is our missing side length. Let's first evaluate these powers just to get them out of the way. 6 squared I know is 36, and then plus b squared, we have no idea what that is, so we just have to keep it as plus b squared, equals 14 squared, which is 196. Now we want to get b squared all by itself. Notice it's 36 plus b squared equals 196. If we're going to get b squared by itself, we got to move this 36 over, right? This is a positive 36 right here that's causing us some trouble. To get rid of a positive 36, let's just minus 36 on both sides. Whatever you do in an equation on one side of the equal sign, you have to do to the other side of the equal sign. Because remember, an equal sign is kind of like you have a balanced scale, right? And if you have a bunch of stuff over here and a bunch of stuff over here, if you take something away from here, you have to take the same amount away from here for it to stay balanced, right? So that's why when you have an equal sign, you got to take away the same amount on both sides. Anyway, I'm just rambling here. Minus 36 from both sides, that gets rid of it here. So we have b squared equals 196 minus 36, which is 160. And then we want to find what b is. To get rid of the squared, we just square root both sides. So the square root of b squared, of course, is just b. That's why we did that in the first place. The square root of 160, though, and I'm just going to round to the nearest hundredth. I really should have told you what to round to in the first place. I apologize. If you round to the nearest tenth, that was fine too. But round to the nearest hundredth, I got 12.65, and that would be centimeters. So we know that this side length B is 12.65 centimeters. Now we're almost done. We were asked in the first place to find the perimeter of this right triangle. The perimeter is the distance along the outside edge. So in other words, just add up all three of your sides. This is going to be 6 plus 14 plus 12.65. Throw that in your calculator if you wish, or if you got good mental math, you'll be able to figure it out. It's 32.65 centimeters. Do not forget your centimeters. Make sure you include your units on that. And also, as always, try to box your answers. It makes your life a lot easier, and it makes my life easier too. If I'm marking something, right, I can see, hey, you know exactly what your answer is, and you felt confident in putting a box around it. Anyway, one last question here. A square pool that is 20 feet long is going to have a 4 feet wide paved sidewalk around it. The sidewalk will cost $10 per square foot. How much will it cost to pave around this pool? We did a question like this, like almost identical to this not that long ago. Pause the video here, give it a try. And aside from that, I'll go over it. Personally, I'm someone who wants a picture, right? So I'm going to draw a picture of this square pool. I'll draw it like this. Here it is. That's the pool. We know it has a side length of 20 feet. And since it's square, we know it's 20 feet all the way around, right? 20 feet on all four sides, right? Now it's going to have a 4 feet wide paved sidewalk around it. So if we drew a sidewalk going around the outside of this pool, it's going to look something like this. And we know that the width of this sidewalk, like anywhere along here, is 4 feet. So like 4 feet wide there, and then like 4 feet wide there, and then 4 feet wide here, and 4 feet wide here. You get the idea, right? It's not a perfect diagram, but you get the idea. So the sidewalk is going to cost $10 per square foot. So we're just putting sidewalk in on like this little like rim piece right here, this little area all around the edge, right? The trick behind this is find the area of the big shape and then take away the area of the little shape inside of it to find just the area of the trim. Well, if you think about the fact that we have a 4-foot sidewalk on both sides of this pool, notice the side length of this whole thing, the whole big shape is going to be 20 feet here, but then plus 4 feet here and another 4 feet here. So 20 plus 4 means we have a 28-foot side along this side here. Along this side, however, we have another 28-foot side. And then you can say the same as here and here. Now, since it's costing us $10 per square foot, we should find the area of our sidewalk. Area is just length times width. So if we go 28 times itself, so 28 squared, and we subtract the pool from that, which is just going to be 20 squared, that'll tell us the area of the sidewalk. So 28 squared, first of all, throwing that in my calculator, 28 squared is 784, minus 20 squared is 400. That gives me, if I subtract those two together, it's going to be 384, and that is square feet. Now, it costs us $10 per square foot to pave this. So if I multiply that square footage by $10 per each of those square feet, you're going to get a grand total of $3,840 being the cost of paving around that pool, right? So basically, you just find how many square feet you have. Square feet is a measure of area, after all. And then just multiply by what it costs per square foot, right? If this question instead said it costs like $6 per square foot, you just multiply by $6 instead, right? Anyway, hopefully that was pretty clear. I know we've done a few like that before, but if they're still tough for you, make sure you're looking over your notes and practicing them, or even trying some of the textbook questions like these right here. So for practice, complete your exponent laws booklet project. That is going to be due on the next day, actually. So like Wednesday, if you're watching this in 2022. If you're finished, then make sure you're working on page 122, which is questions 3 to 14. They'll have a lot of really good questions in there, kind of like what we've done today, just to make sure you're really understanding this. Our unit exam is going to be the end of the week. It's going to be on Friday, at least if you're in 2022 right now. Anyway, if you need any help, please reach out, whether it's to your peers or whether it's to me. Best of luck.